Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answer. For the factoring, you should have x plus 6 times x plus 1. Okay. For the math knowledge question, they give you extra information. All it asks for an expression for the number of miles per gallon that the car averaged. So miles per gallon. The number of miles that they drove, 280. The number of gallons that they used, 18. And so 280 over 18 is the miles per gallon that they averaged. A money amount was just extra to throw you off. So that would be the answer you would want to pick. We're looking at lesson 21 today. We're going to be evaluating functions. We're going to look at domain and range, different types of functions, and then tests for functions. So hopefully you'll understand how to evaluate functions, you'll understand domain and range, the types of functions, and the tests for functions after this lesson. So starting off with a function, it's a single valued expression. X is going to be your independent variable, and Y is going to be the dependent variable. And we're going to use the notion f of x, f parentheses x parentheses, which you read f of x, instead of writing y. F of x is synonymous with y though. They mean the same thing. They can be interchanged. It's just a way to write function instead of an equation. So on this one, we want to evaluate this function. It says f of x equals x squared plus x and minus 10. So some of y'all may remember this from Algebra 2. We are looking for f of 5. So right now we have f of x. So we're going to replace our x with 5. And then everywhere in our equation that we have an x, we put a 5. All this is saying is evaluate at x equals 5. That's all that you're supposed to do. So f of 5 equals 25 plus 5 minus 10. So f of 5 equals 20. And that's your answer. Do not solve for f. Do not try and solve for f. We were asked to find f of 5. It's not f times 5. It's a function evaluated at 5. So, not trying to solve for your variable. F of 5 is 20. That's your answer. Stop there. Looking at another one. If you think you can do this one by yourself, y'all go for it. It's a little bit different, so if y'all aren't comfortable with it, that's fine. For this one, we're looking for f of x plus 2. So we're going to do f of x plus 2. So everywhere we have an x, we're going to replace it with x plus 2. So here we have x squared. Instead of x squared, it's going to become x plus 2 squared, and then plus 1. Okay? So anytime you have x plus something, you need to put that in parentheses wherever your x was originally. From there, we're going to distribute. So we would have x squared plus 4x plus 4, and then plus 1, which is going to give you x squared plus 4x plus 5. And so that would be f of x plus 2. So that's how those work. Looking at another function, they tell us we want to find 4 square root of 3 times h of 30. So our h function is h of theta equals sine of theta. So what we're going to do, instead of theta, we're going to put a 30 in here. So h of 30 is going to be the same thing as sine of 30. Okay? So let's look back at our triangle. This is square root of 3, this is 1, and this is 2. The sine of 30 is opposite over hypotenuse, which is 1/2. So h of 30 is equal to 1/2. So coming back to this right here, we have 4 square root of 3, and then we have h 30 degrees. We found that h of 30 was 1/2. So instead of h of 30, we're going to put 1/2. So we'll have 4 square roots of 3, and then we'll have a 1/2. And then if you multiply those two together, you're going to end up with 2 square roots of 3. And so that would be your answer for that one. All right, so now we're going to look at domain and range. So a function is a mapping or a correspondence between two sets. One that's called the domain, and the other is called the range. And for a function, every domain corresponds exactly with one thing in the range. So people like, or books like to use charts like this. And we have a number, another number, another number. For a function, this one here in the domain is going to go to only one value in the range. This one here is going to go to another value in our range. Okay, now if I left it like this, this would not be a function because this number is not going to any number in the range. So it has to go to exactly one member over here. Now if I took this one and put it going also to this number, this is a function because every domain is going to one range value. Okay, however, if I had it going where this one was going to two different values in the range, this would not be a function. So it's okay for your ranges to repeat. Your domain, though, cannot repeat. So let's look here. We want to find the domain of f. So your domain is related to your x values. We want to know what x values can go into this function. Can we plug in 10? Can we plug in 20? Can we plug in negative 100? Can we plug in 0? What numbers can we plug in? When you have a radical, the part under the radical has to be greater than or equal to 0. So 10 minus x has to be greater than or equal to 0 because it has to be positive. So if I subtract 10, I get x is greater than or equal to negative 10. And then I can divide by negative 1. And that would give me that x is less than or equal to positive 10. Because remember, when you divide by negative, this sign flips. So this is our restriction on our x. We can plug in 10 and any number smaller than that. But if we plug in 11, it won't work. Or if we plug in 10.01, it won't work. So the way that you write domain, you can write out domain or you can just do D. I do just D for domain shortcut. It's the set of numbers such that x is in the reals, or x is an element of the reals. This is an E. It kind of looks like a C with a line there. But x is an element of the reals such that that's a vertical line. And then this part right here, x is less than or equal to 10. So this would be your answer for your domain. Okay, so that's how that works. Looking at another one, we want to find the domain of this function. So we don't have any radicals, so we don't have to worry about that, but we have a fraction. And we know that our fractions cannot have a 0 in the denominator. So x minus 2 cannot equal 0 because you can't divide by 0. So that means that x cannot equal a positive 2. So the domain on this one, x is an element of the reals such that x does not equal 2. And so that would be your domain there. Okay. We're going to try another one. If you feel like you can find the domain of this function, go ahead and do that. If you think you can do the range, you can do that one as well. We haven't talked about doing range yet, so y'all may not be familiar with that one. But y'all see if you can do the domain real quick all by yourself. All right, so for domain, we know that what's under the radical has to be greater than or equal to 0. So that means x is in the reals such that x has to be greater than or equal to 0, because what's here has to be 0 or bigger. Now for the range. When you do it, it's a set of y values. So y is in the reals such that, what numbers do we get out when we take the square root of something? When you plug it into your calculator, what kind of numbers does it give you? It only gives you positive numbers. When we take the square root of something, we put a plus or minus, but the calculator only gives you the positive value. We're doing that because algebraically that could have happened. But for square roots, y is always going to end up being a positive number. So 0 or bigger. Because the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2. They're always going to be positive numbers. Okay, so that would be your domain and range. Now we want to graph it. So all you're going to do is a t-chart. 0, 1, and 4 are numbers that we can take the square roots of. And that gives you 0, 1, and 2. So there you go. And you can also do 9 and 3. But that would be your graph. Okay, so that's how that one would work. Notice that our x values are all not over here, they're all 0 and more. And same thing with our y's. They're not down here, it's 0 and above. Okay, we're going to look at another one. So I want y'all to pause the video and try and find the domain and range for this one. Okay, for the domain, x is in the reals such that we know that x plus 4 has to be greater than or equal to 0. So that means that x has to be greater than or equal to -4. And then for your range, your y is in the reals such that when we take the square root, we always get 0 or greater. So y is greater than or equal to 0. So that would be your answer for that. And now we have to graph it. So if I plug in 0, 0 plus 4, square root of 4 is 2. So I get 0, 2. If I plug in 1, that doesn't really help because that's going to be the square root of 5. If I plug in 2, square root of 6, 3, square root of 7, 4 would be the square root of 8, 5. I can plug in 5, and that would be the square root of 9, which is 3. So there are 2 points. But we need to go into the negative numbers to figure out more what it looks like. Because it's still going to be that shape. We just don't know where it's going to start. Or we haven't gotten there yet. So let's try -1. If I plugged in -1, that'd be square root of 3. Don't know that one. -2 would be 2. So -3 would be 1. So the square root of 1 would be 1. So -3, 1 would be a point. And then if I plug in -4, I would get 0. And so those would be the points that you can have. And so that would be the graph of your function. Okay, so that's how it works. We're going to look at one more, trying to find the domain and range. So I want you to see if you can get the domain and range of this function. And then I will go over it. Alright, for the domain, if you get this, that's awesome. If not, that's okay. We just started doing this, and it's very common for people to take a little bit before they get all of the parts. So we know that x is going to be in the reals. In our radical, x has to be greater than or equal to 0. And that's all that there is for that one. But also, the the denominator cannot be equal to 0. So x cannot equal 2. So that would be your domain. You have 2 parts. X has to be greater than 0 and cannot equal 2. For the range, the numerator is always going to be 0 or a positive number. Because you're taking the square root of a number, it's always going to be positive, or it could be 0. If it's 0, though, that means 0 minus 2. That would be a negative number. This is always positive, and then this number can be either positive or negative. And we can get 0 because 0 over negative 2 is 0. So 0 works as it's a range value. That's what we could get. But we could get a positive over a positive or a positive over a negative. So the way that you do your range for this one is actually just going to be like that. Y is in the reals. And it's your real values. It's all reals because we can get 0, we can get positive values, and we can get negative values. And so there's no restriction on our range because we can get all types of values. So that would be your answer for that one. So when you're looking for domain and range, for domain, the two parts that you mainly want to look at is your denominator cannot equal 0, and the parts under the radical have to be greater than or equal to 0. And if you do those two, typically that's all you're going to be able to do. So domain is two parts mainly. Radicals have to be greater than or equal to 0. Denominator has to be not equal to 0. All right, so now we're going to look at a function machine. This is what I drew earlier. It has types of functions. Every x value goes to only one y value. That's a function. So looking here, this is a function because every x goes to only one y. This is called a relation because this one went to two different values. So it's not a function. This one is not a function or a relation because we've got this one that doesn't go anywhere. And then if it's a one-to-one, every domain goes to only one range value and vice versa. One domain to one range only. So these are mappings or correspondences. They like to ask about these sometimes. But this is a function and this is a function, but these are not functions. So if y'all want to graph these or draw these out real quick, you can, and then y'all can unpause the video. So we use the word function whenever we are mapping an input set, your domain, going to an output set, the range. So whenever we're describing a mapping, that's when we would use the word function. So we want to determine whether these functions, these maps, determine a function. So let's look at the first one. Is every x going to only one y value? Yes. So it is a function. For this one, is every x going to only one y value? Well, the 7 is, but the 5 is going to two different values. So it's not a function. Okay, for C, every x is going to one y value, except for this m. So that means that it is not a function. And then for this last one, the way that it's worded is weird. But it says we have any real number. For every real number, we plug it in and we add 2 to it. Is that going to produce only one value for every number that we plug in for x? Yes. And so this is a function. This is an equation of a line, and a line is a function. So that's also how you can know for sure that it is a function. Because the line has, for every x value, only one y value. Okay, so now we're going to look at this one. They asked about ordered pairs. Which one of these are functions? So again, the x's, if they repeat, the y value, if the x's repeat and the y value is different, that means it's not a function. So what we want to look at, do our x's repeat? So I have a 1, a 2, a 3, and a 4. My x's did not repeat, so this is a function. Looking at this one, I have a 1, a 2, a 1, and a 4. So I have two x values that repeated. They have different y values, so that means that this is not a function. Looking at this next one, I have 4, 2, 4, and 3. So I have x values repeated, However, it's the same point, 4, 3, both times. So this one is a function because the x value repeated, but it was the same y value. So they just wrote the point twice, basically. So that one is a function. Now we have 1, 4, -1, and 3. That is a function because none of our x values repeated. Okay, so that's how you can do them if they have an ordered pair. So now we're going to look at our test for functions. You have the vertical line test and the horizontal line test. The vertical line test tells you if you have a function. And so to do the vertical, or for it to pass the vertical line test, you're going to draw vertical lines, and your graph can only intersect it at most at one point. So if I have a circle and I drew a vertical line, it does not pass because it touches the graph at 2 points. So a circle is not a function. So let's look here. Here's a circle. It's not a function. But over here, this is a function because every vertical line that I draw passes the vertical line test. If I had, let's say I did a function and then I did this, or I did a graph. Right now it's a function because it only touches once. Here it's a function because it's only touching once. Over here it's a function, but this vertical line crosses it more than one time. So this is not a function because it did not pass the vertical line test at the entire time. So it passed it at some parts, but that still doesn't make it a function. It has to pass it for the whole thing. Okay, so let's look now at the horizontal line test. The horizontal line test you only do if it passes the vertical line test. So if it doesn't pass the vertical line test, then you stop right there. If it passes the vertical line test, then you go on to the horizontal line test. And it tells you if you have a one-to-one function. And just like the vertical line test, for the horizontal line test, you draw a horizontal line. And then it can only cross your graph in at most one spot. So it's horizontal, but you do the same thing. If it touches it more than once, then it's not a one-to-one function. So let's look at this example, or this graph. This is a function because everywhere it crossed the vertical line test, it passed it. Everything only touched one time. And so now we try the horizontal line test, and it crosses at one spot every time. So this is a one-to-one function. Now this parabola, every vertical line it passed. But when we go to do the horizontal line test, it touches it more than one spot. So this is a function, but it's not one-to-one because it didn't pass the horizontal line test. Okay, so on your homework and on your test, it gives you A, B, C, and D. This is not a multiple choice part question. It's not A, B, C, or D is your answer. It's a 4-part question. So you have to get all 4 of them correct to get the question right. So for the first one, it asks if it's a function, and if so, is it a one-to-one function? So for part A, is it a function? Well, let's draw a vertical line. Did it pass the vertical line test? No. So it is not a function. That means that we move on. It wasn't a function, so we don't have to worry about the one-to-one part. For this next one, vertical line test, it passes. So is it a function? Yes. Now let's check the horizontal line test. It passes it everywhere. So yes, it is a function. And it is a one-to-one function. Looking at this next one. Is it a function? Well, it passes the vertical line test. So yes, it is a function. Now let's look at the horizontal line test. If I draw a horizontal line here, how many places does it touch that graph? At all of them, basically, because infinitely many places, it's right on top of it. So this is not a one-to-one function because it does not pass the horizontal line test. Okay, and then looking at this one. Is it a function? here it is, here it is, here it is, here it is. But this line right here is the one that is giving the trouble. It is not a function because at this spot right here, there are two values, two places where it hits that line. So this is not a function because it has 2 points for this one line. This one over here had an open circle, and so that's why it was a function. If this had been colored in, this would not be a function because it would have not passed the vertical line test. So that's how the graphs work. So you can say function, one-to-one function, or whatever, or you can just do yes and no. Either one is fine with me. Okay, so now we're going to look at your homework real quick. You have to omit number 13, 14, and 26. You need to do the other 27 for homework so that we can go over any questions you have tomorrow.